Get out 4-6. I want to look at number 10. Please and thank you. You have to call me God, Mr. Davis. What am I looking at?
How I'm supposed to be in this game. I'm like,
You're asking like what I'm doing?
yeah, that's what I've never been in this situation.
You got more pawns, so I'd be trying to get one to the other side.
Right.
I don't want to tell you what I'm doing. If you win, I know what it is.
My,
I want you to know back.
I thought was this.
Yeah, so then
But I almost have to wait and get the king over and take this pawn. That way, whatever he does, he can't move.
wait, go back to your first one.
I like it too.
So what's wrong with it? Because now he's got to either take your pawn, and then you gotta, then you're past it,
Oh, right.
or he doesn't,
Or he
then
goes
you're
this
past
way.
it.
Or he goes that way. With his bishop. That's why I
Okay,
go.
so what are you saying then?
So I go here first. It's faster. He does. He can't.
Say he moves his pawn, well, I don't believe it. Say he just moves his king in a round spot.
Yeah.
So then, like,
Right. So then I do that. And now if he takes this way, then I get the this way with the pawn. And now I'm so.
okay.
Right?
Yeah, it's kind of it's a longer journey to the
It
other
is,
end,
but
but
I'm
I
not
think
sure I
you're
got
probably
a choice.
yeah. I think if you're down to like just the bishop, it's like it's a bishop
Yeah,
material.
you can't win. Right.
Okay. Did we try this yet? Like, try to go through it, or should we jump for it? Try it, didn't go well. Didn't go well. Okay. So this is time versus the rate of change of snow. So this is like there's snow falling. This is the depth of the snow. We know it's concave down, but that doesn't matter until part C. And I want to calculate S double prime of time. So this table here is S prime. So I want to go to S double prime. So how do I go down a level? I take the derivative, but there's no equation, so I look at the slope. So you're both right. So I take the slope, and 10 is like right in the middle of 9 and 12, so I would find the slope between these 2 points. So I would do 1.3 minus 1.6 over 12 minus 9. So it's just like y2 minus y1 over x2 minus x2. And so that's negative 0.3 over 3. So you could just, I would probably just leave it. That's negative 0.1, but there's no real advantage to doing that. And if I was at centimeters per hour, think about this over here, and I take the derivative, where am I now? Centimeters per hour, or centimeters per hour squared, either way. I just realized that Noah's wrong. He answered a lot of these questions. So centimeters per hour squared, or
Please excuse the interruption. Big Red Buddy bowling trip is meeting in the main rotunda.
someone in my afternoon that's very loud. Okay. So explain the meaning of it. So this is the change in the depth of the snow. So the depth of the snow is increasing. Well, actually, it's kind of going up and down. How's that happening? Oh, the snowfall. Yeah, yeah. The snowfall per hour is changing. Thank you. I was thinking the depth, which is not the right level. Depth would be here. This is the snowfall per hour, and this is the change in the snowfall per hour. It's the rate of change of the snowfall is changing. So the change in the snowfall is getting, like the snowfall itself is getting faster, or the snow this is the, or you could say like the acceleration, if you want to throw it in those terms, of the snowfall. Or you could say like the change in the rate of the snowfall. It's the same idea. Is that alright for that one? So part B, is there a time between 0 and 12 where the rate is changing, where the depth of snow is changing at a rate of 1.5 centimeters per hour? So this table is centimeters per hour. If you remember the intermediate value theorem. So because this is differentiable, I know it's continuous, which means like I'm not picking up my pen. So I can't get from 1.8 to 2.4 without hitting every single value in between those. That's the intermediate value theorem. Well, 1.5 is not in between those, but it's not between those, and it's not between those. And you might hit 1.5 in here. Like, I have no idea what happens. It might go down to 1.4, and then up to 2, and then down to 2.1, and then 2. But I know that I can't get from 1.6 to 1.3 without crossing through 1.5. So all you've got to say is you can just say IVT, actually, by the intermediate value theorem, yes, between 9 and 12. Or, if you forget what it's called, you can, like, describe it. So you might get to the test or AP test, and, like, I know this thing, I just forgot what it's called, just explain it. Yes, since continuous, to go from 1.6 to 1.3, you must pass through 1.5. And then you would say, which happens between 9 and 12. Something like that. That's part B. I wrote it up here just because I didn't want to write right on there. Is that okay for part A? Or part B? So if I said, is there a time where the centimeters per second is 2.3? Maybe rephrase it. How many times? At least how many times is the centimeters per hour 2.3? At least twice. So I pass through 2.3 from there to there, and again from there to there. Could it be 2.3 over here, like somewhere between 4 and 9? Yeah, but I don't have a guarantee of that. Is there any time when I know that it's 1.2? No, because 1.2 is not between any of these pairs of numbers. But I think part C is the stuff we're doing. This unit, this section. Am I just stupid, or is there no bar there? Isn't there another page?
It's on right there. It's about just keep up. No, it's on the right. Yeah, there it is. The right side. It's there now. It wasn't there. It wasn't
What the
there.
heck?
Yeah. It wasn't
Okay.
there.
At t equals 4, the depth of the snow is 28 centimeters. That's basically like my x and y value. Use the line tangent to approximate the depth at t equals 6. I know from above it is concave. Remind me. Concave up or concave down? Concave down, thank you. So I'm going to use the local linearity, the equation of the tangent line, and we'll figure out if that's an overestimate or an underestimate. So remember, this is in centimeters. So at t equals 4, the snow has a depth of 28 centimeters. This is my slope. What's the label for slope? If my original level is centimeters, what's the label for the derivative or for the slope? So think about this. It would be centimeters per hour, wouldn't it? What does that table tell us? Centimeters per hour. So what's the centimeters per hour when x equals, or when t equals 4? I'm like legit asking because I can't see the table. 2? Okay. So there is your tangent line. So So this is the t equals 4 went there, centimeters went there because this is in centimeters. That is a derivative, so now it's got to be in centimeters per hour. So that's why I just went off the chart to get that. And then I'm going to plug in 6. 2 times 6 minus 4 plus 28. So 2 times 2. So 4 plus 38 is 32. What is my label there? That's just in centimeters. That's like the original level, the y. And then if my original was concave down, and I'm estimating with a line, didn't I go over the top of it? So then it's going to be an overestimate. You have to justify your answer, so you can say overestimate. Since f of x is concave down. That's like, that could be, so there's like 6 free responses in the A/B test. And I just gotta wait till the end of the year to practice those. A, to make sure we get through the material, and then B, while we're practicing them, and also just review them. And actually C, most free response on the A/B test you can't do until you get through, because we're doing derivatives and then we're doing integrals, which is backwards. Most free response questions you can't do until you get through. So if you're wondering why we haven't done any free responses, there's 3 reasons. But this could be one. Like, that's a legit 3-part question that hits a bunch of different topics. It's a good one. Questions on that one at all? Alright, let's look at course 7. It's good. We don't even do the whole book. Alright. So we're going back to limits. So you can use derivatives to kind of shortcut some of the limits. We didn't teach this when we did limits because you didn't know derivatives. There's some teachers that wait and don't do limits until after they do derivatives, because then you can like apply this rule. Until they have a lot of problems. But to me, then you're missing some of the concepts that matter when we're learning limits. But remember, the first thing you would try to do with any limit question is just plug in. Like if I get 2x minus 5 over x like they have here, I'm going to get 2 times 3 minus 5 over 3. So that'd be 1/3. I don't have any issues there. The problem is when, on a lot of these that we did before, you run into either 0 over 0 or infinity over infinity. And then you have to find another technique. So in this one, if I plugged in right now, I would get 0 over 0. And then back in the limits chapter, if you remember what we did, I can factor that top, like multiply to 10, add to -7, so that'd be x minus 2, x minus 5, and I cancel those, then I try to plug in again, so now I can plug in 2, so 2 minus 5 is -3. That's still a perfectly valid way to do that problem. But sometimes the factoring didn't work, the rationalizing didn't work, and we're still kind of stuck. So let me show you another way to do that problem. So I go to plug in, I get 0 over 0. And then what the L'Hopital's rule says is you can take the derivative of the top and the derivative of the bottom and then try to plug in again. So if I take the derivative of the top, so now I've got limit of x approaches to the derivative of x squared minus 7x plus 10 would be 2x minus 7, right? And what's the derivative at the bottom? Oh, I'm going to get the same answer. I was really stumped for a second. Okay. Now plug in 2. 2 times 2 minus 7 is not also -3. It's that simple. Not all the derivatives are that simple. But this always works. If you get 0 over 0 or infinity over infinity, take the derivative of the top and the bottom, which is different than quotient rule. Like we're not doing quotient rule. It looks like it's a division, so I think a lot of people are going to be, it's easy to confuse those two. But so the rule is if I have the limit as x approaches a and I get 0 over 0, then you can take the limit as x approaches a of f prime of x over g prime of x. So you're separately taking the derivative of the top and the bottom. Which is not what we do in quotient rule. I like these questions because he threw some quotient rule ones in there just to like make sure you pay attention to both. So let me do, I think there's 4 on here. Sometimes you have to apply the rule more than once, which happens in number 5. And I know on some of these there's a different way to do it, but I'm just kind of bypassing that and trying to show you how to do it using L'Hopital's. So in this one, if I plugged in 2, I would get 0 over 0. You should, the first thing you should do with any limit question is plug in, because there's a chance you won't have to do anything else. Like on that first one. So yeah, you always plug in first. And then if it's L'Hopital's, I want to write 0 over 0 or infinity over infinity. Because on a free response, they would want to know, okay, you understand you got 0 over 0, now we know you're about to use L'Hopital's. Actually, I think they want this. So you do that. When I plugged in, you're telling the person grading it. This is if it's on a free response. You're telling the person grading it, I plugged in and got 0 over 0. I'm about to use L'Hopital's. So heads up. So then I'm going to take the derivative of the top and the bottom. So the derivative of the top is just 1. Derivative of the bottom would be 9x squared minus 12x plus 1. And like, what can I do now that didn't work a step ago? I can plug in 2. That's the point. So I couldn't plug in 2 because I got 0 over 0. Hey, I'm going to use L'Hopital's rule. So I take the derivative of the top and the derivative of the bottom, and I go to plug in again. So it's 1 over 9 times 2 squared minus 12 times 2 plus 1. And honestly, I would just stop. Like, there's no benefit to going past that. It would be 1 over 13, I think. Is that right? But there's no advantage to that. Questions on what I did with that one? Why did you do this? What about this? So I'm doing 3. If I go to plug in like sine of 6 times 0 over 0, well, that's sine of 0 over 0. Remember, sine is your y value, so if I'm at 0 degrees, my y value is 0, right? So I'll get 0 over 0. Okay, I'm going to use L'Hopital's rule. And then I'm going to take the derivative of the top and the derivative of the bottom. So, the derivative of sine of x, remember that's chain rule, so the derivative of sine is cos. Leave the 6x alone and then multiply by the derivative of the inside, which is 6. Over, and now the bottom is just 1. And now I can plug in 0. So this would be the cosine of 0, because 0 times 6 is 0. So the cosine of 0 degrees is 1, right? So 1 times 6. And I can say that's 6. If you remember way back in the day, we had that rule that if it was like sine of ax over x, so the limit as x approaches 0, we called it like sine of ax over bx. Your limit would just be a over b. So basically you take that coefficient divided by that coefficient, which if you notice would also give you 6 over 1. So it's still 6. So like we knew how to do it before. This way is probably easier because you don't have to remember the rule. But so in a lot of these limit questions, there's kind of 2 ways to get to it. Questions on 2 there? And 3. Cosine of 0 is 1, so 1 minus 1 is 0 on top, 0 squared, so I will get 0 over 0. I was just realizing, like, I went to this conference and they were like, yeah, just write LH, that stands for L'Hopital's rule. But no, it freaking doesn't. It stands for L'Hopital. Like, there's no, I don't know. They said it was fine. Like, this is a greater for the AP test. So they said LH was fine, but shouldn't it be like LR or LHR? Whatever. Pick some letters and throw it in. Rule. just realized that like right now. So. Okay. So then I'm gonna go take the derivative of the top and the bottom. So the derivative of 1 is nothing. What's the derivative of negative cosine? Positive sine. And the derivative of the bottom is 2x, so it's not quotient rule, it's two separate derivatives. And then if you plug it now, it'll work. Will it? Wait, why not? Yeah, okay, so I get 0 over 0. So what's sine of 0? What's the y value here? And then what's 2 times 0? Alright, then I gotta do it again. You can just keep doing it until it works. So now, I'm going to take the derivative of what I had here. So what's the derivative of sine of x? Cosine of x. Derivative of 2x is 2. Now I can plug in 0. So the first attempt at L'Hopital's didn't work. We just do it again. So now it'll be cosine of 0 over 2, which is 1 over 2. Is that alright? The idea, the main point there is like if it doesn't work the first time, just try again. Just keep going. Pop a squat. Is that alright for 3? Or 4? Then number 5. So this is an infinity one, which what we're looking for in this case is like the higher power. So, but these got confusing for some people, and you got to remember it. So let's say I didn't know where the higher power. Well, where is the higher power? On the bottom, because I'm thinking about plugging in infinity, right? On top, my power is 2. On the bottom, it's going to be like 2 times infinity. So the bottom power is bigger. Do we remember what the answer is when the bottom power is bigger? 0. Good. But let's say you didn't remember. Let's just practice L'Hopital's. So I would plug in infinity here. That would give me infinity over infinity. Well, that's the same idea as 0 over 0. Like that's indeterminate. I don't know what that means. I can't do anything with that. So then I'm allowed to apply L'Hopital's rule. So then I'm going to go, okay, the limit as x approaches infinity. Derivative of 2x squared is 4x. The derivative of e to the 2x would be e to the 2x times 2, right? You have that chain rule piece from the top. So plug in infinity again. Like again, I forgot the horizontal asymptote rule. Like I forgot the bigger power situation. So I'm just going to plow through L'Hopital's. Well, 4 times infinity is infinity. E to the power of infinity is infinity. I still don't know. So I'm going to do it again. So now I get to limit as x approaches infinity. So what's the derivative of 4? The derivative of 4x is 4. I just told you. And then this is really like 2e to the 2x. So your derivative would be 2e to the 2x times 2. So now if I plug in infinity, I get 4 over infinity. So what's 4 divided by a gigantic number? It's 0. So like at that one, you're probably way better off if you remember the higher power thing. But if you don't, then just to practice L'Hopital's. If you don't, L'Hopital's will work. Questions on any of those? And then this number 6 he's got here, I think, just to make sure you actually remember quotient rule. So if you're doing quotient rule, you still have to do minus give. You can't take the derivative by just taking the derivative of the top and taking the derivative of the bottom. So this is here just to remind you, in this situation, I would have to do f prime times g minus g prime times f over the bottom square. Thank you. That's an honor, man. Sometimes I look back and you guys have your head down, you're writing, I'm like, is anyone actually writing that? But then I make a mistake because they're all of it. You should just make it on purpose. It's totally why I do it. if anyone's like worked ahead and you have any ones that like here, yeah. Number 6, like that's the derivative problem. It's saying take the derivative, so that's quotient. L'Hopital is when you're asking to do a limit. So that's the main difference. I think he's afraid because when you do the limit, you just like L'Hopital's rule is you just take the derivative of top and you just take the derivative of bottom. So we want to make sure you're not applying that to quotient rule also. Because quotient rule still exists. Yeah.
Number 14 is really weird. Yeah.
Ooh, that was a good counter.
He's explaining the problem.
Yeah, that was a decent counter.
Yeah, but having him do an example would help you learn. Which is the point of him being there, is to help us learn.
We all just get along.
It's not.
Go ahead and start working. This might take me a second to figure out actually.
The rest of it's fine.
Is it just 2/3?
Yeah. But it was just like their little thing.
Oh yeah. I did like a derivative. Well, see what happens if the teacher he screws up. Does that help then? So do you remember the like rule where you can break it down?
Because like once the little answer, they just said like 2/3, but then on top it said we prop vlogs, and I was like, wow.
Oh, okay. I didn't look at the
Yeah.
questions yet. And then once you get to here, like these are the same, like
Yeah, like that makes sense.
exponent. And you can,
Like doing the actual math, but they were just like property of vlogs, and I was like, okay, cool.
cool.
Cool. Do I know what it is? Yeah.
Cute.
Do I remember it? No. Cute.
So go ahead and get to work and let me know what I can do to help. I already put the review for your test on Schoology and the answers. So remember your test is Wednesday. You'll have Monday and Tuesday. I was kind of had like a buffer day in case we needed more time on a section. But it seemed like we had to do a section. And if we didn't, when you guys did the review, it'll kind of pop up like, oh, we need more time. Whatever. We got 2 days, which I think is more than enough. Which I'm fine with. Not like we're starting exactly before break. So
Are we two-parted then? Or is it all no calculation?
don't know. Can I tell you Monday?
Oh, I don't care. No, Monday. Just giving you some